part of the exam review, we're going to go over the circle equation. We're going to start back with a couple of the very basics and then move quickly ahead to the other more complicated equations. Okay? So here's one that you would have been given at the very beginning of the circle unit where you were asked to complete the square. So you had to say what value for C would complete the square for my x's, what value of D would complete the square for my y's. X's are a little easier, the y's are a little harder. We'll see why here. So for the value of C here, we said that the method that we would use is to take half of 6 and then square it. Okay? So half of 6 would be 3, 3 squared would be 9. Now for D, it's a little harder. Half of -7, well, that gives you a decimal. And we don't want to work with decimals and trying to square decimals, but I can write -7 as a fraction, dividing in half as -7 over 2. Okay? So there's -7 divided in half, and you square it. So -7 squared is going to give me 49. 2 squared is going to give me 4, so you get 49 over 4. Now, completing the square for a complete equation. Notice in the one above, the x's were put together, and then a blank left for completing the square. The y's were put together, and then a blank for completing the square. In this particular one, and this is the equation of the square in general form, the x's aren't together, the y's aren't together, and there are no spaces for completing the square. So I'm going to have to do that myself. I'm going to put the x's together, so I have an x squared plus 10x, and then a blank for completing the square. Then I'm going to put my y's together, so I have a y squared minus 8y, a blank for completing the square. And I'm going to take this -8 to the other side. Okay, so if I take that over to the other side, it becomes just a +8. Now I need to actually fill in the blanks with the number that would allow me to complete the square. So again, the same method here. I have to take half of 10, which is 5. 5 squared gives me 25, so I'm going to add 25. Now, different from what we were doing before, that 25 was not there before, and I've added it so that I can complete the square and factor this as x plus something times itself. So the 25 was not there before. Since I added it there, I have to also add it to the right side in order to balance things. Half of -8 is -4. -4 squared is 16. Again, that 16 was not there before. Okay, there was nothing there before. I artificially added 16 to the left side, so I have to add 16 over here. Now, the whole point of doing this, right, was to be able to write this as a factor times itself. Okay? And if you didn't know that this was the equation of the square, and I gave you just this, and I said factor it, you'd be saying what two numbers add to a +10 and multiply to a +25. Well, then you would say 5 and 5. So it's x plus 5 times x plus 5, which is x plus 5 squared. And again, that's the reason we put the 25 in there, was so that we can factor this. Next, we have a +16. Y squared minus 8y plus 16. So you think of two numbers that add -8 that multiply to a +16. Well, that's a -4 and a -4. So there we have that part. Then finally on the end, okay, I have a 16 and 35 and 25, so that gives me 41. 41 plus 8 gives me 49. So there's the equation of my circle in standard form. So right here, we started off general. So there's general form, standard form. Let's just do one more. Let's do the mapping notation here. So before I do the mapping notation, I would probably say where the center of my circle is and what its radius is. So the center is at the opposite value of this in the x and the opposite value of this in the y. Okay, so my center is going to be at -5 in the x and +4 in the y. And your radius is the square root of this number. Okay, so the square root of 49 is 7. Usually that works out to be a nice number. Most of the questions I'm going to give you. If this wasn't a nice number that you could take to the square root of, say it was 50 instead, and I said, well, what's the radius? Then you would leave it as this. You wouldn't put the square root of 50 in your calculator. You would leave it like that. That should be simplified, but we won't go into that. Okay, so leave it like that if it doesn't work out to be a nice even number. Okay. One more thing, the circles. Okay, let's start out with this one, okay, in standard form, and let's put it into general form. That's the other direction we're usually going to go. Okay. So, to do that, I'm actually going to multiply this out. So x minus 2 squared means x minus 2 times itself twice. I'm going to bring this 10 to the other side as a minus 10. Now you can either multiply this out each individually, okay, these out individually, okay, or if you work with these enough, you can realize that this is an x squared minus 4x plus 4. And multiply this all out, you get a y squared plus 6x plus 9 minus 10 equals 0. If you're wondering how I skipped from this straight to this without going x times x is x squared, x times -2 is -2x, -2x times x is -2x, and -2 times -2 is 4. And this middle number is always double this value, and the end number is always this number squared. Over here, double 3 is 6. 3 squared is 9. Now we collect our like terms. The only terms that are alike are the numbers. And they're collected on the end. So you get x squared plus y squared. My x is -4x. My y is 6y, it should be y. My numbers put together, 4 plus 9 is 13, 13 subtract 10 is 3. So there it is in general form. If I ask for this in mapping notation, right, you would go straight off of the standard form of the equation for the mapping notation. Mapping notation tells you literally where the circle is, and to know literally where the circle is, you need to be looking at the standard form of the equation.